Today we will see the unit 2, the periodic table of the elements, as we discussed in the last class. As per the Pauli's exclusion principle, how first we will see how the electrons are filled. Uh, First, we will see the how the electrons are filled in the electronic configuration. First, we will take 1s to fill the electrons. First, we will take 1s. Next, we will take 2s. 1s, 2s, 2p. Next, we will say 3s, 3p, 3d. Next, 4s, 4p, 4d. So when writing electronic configuration, we will write in this cross. First we will take cross 1s. Next one we will take 2s. Next 2p, 3s. Next which one we will fill? 3p, 4s. Next the filled one is 3d, 4p. Next one we will fill 4d. Based on this, now we will write electronic configuration. So the series which we will take is 1s. Next we will take 2s. Next we will take 2p. Next we will take 3s. Next we will take 3p. Next we will take 4s. Next we will take 3d. Next we will take 4p in the order. Next we will take 4p. Afterwards we will take 4d. How many electrons will fill in each one? This 1, 2, 2, 3, 3, 4, 3, 4, 4. All these numbers are n values. This is n value equal to 1. This 2 means n value equal to 2. Next, this is n value equal to 2. Next, this 3 here. This n value equal to 3. Here, n value equal to 3. Here, n value is equal to 4. Here, n value is equal to 3. Here, n value is equal to 4. Here, n value is equal to 4. If S means L value is equal to 0. If P means L value equal to 1. D, L value 2. F, L value 3. So, how many will fill in 1S? What the possible options of filling is? 1s 2. 2 will fill in S. Next 2s 2. 2 will fill in S. Next is P. Number of electrons is 6. Next 3s. It will fill 2. Next 3p. In P it will fill 6. Next 4s. 2 is filled. Next 3d. In D 10 electrons are filling. In 4p. In P 6 electrons are filling. 4d. In D 10 elements are filling. Let's start it. Cut through. No, 4d 10 electrons are filled. Based on that, now we will see the periodic table. So in periodic table, it is divided into 1s, 2s, number of periods. It is divided as and divided as period 2. So the electron configuration is based on the periods we are classifying. Period 1, period 2, period 3, period 4, period 5, period 6. Based on the periods we are classifying. Period 1, 2, 3, 4, 5, period 6, period 7. Period 1, 2, 3, 4, 5, 6, 7. In this, whatever the period is there, 1s. As per previous, Here, based on this is 1s. First one is 1s. Next second period is categorized as 1s. Next period is categorized as 2s, 2p. Next period is 3s, 3p. Next period is, we are classifying as 4s, 3d, 4p. Next we are categorizing as 5s, 4d, next one is 5s, 4d, 6, 5s, 4d, 5b. Next one we will take 6s, period 6 plus 6s, 4s, 5d, 6p. Next here it will come. Last one is 5f. In this way, each period is characterized. Based on this, we will see here the textbook. The periodic elements. What are the elements we have in the first period? The elements in the first period are the elements in the first period. The elements in the first period have diagram. This one diagram we will see. The elements in the first period. This is 1s. The elements in the first period is 1s. Here it is 1s. Next this is 2s, 2p. Next one is 3s, 3p. Next period is 4s, 3d, 4p. Next one is 5s, 4d, 6, 4d, 5p. Next one is 6s. After 6s, next one whatever will come 4f. Next one it will come 5d. Next one it will come 6p. Next one it will come 4f. Just observe the elements in the first period. We have hydrogen, helium. In the next we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. All noble gases are the last elements in the period. Here we have helium, here we have neon, here we have argon, here krypton, xenon. The last element is the noble element in the periodic table. Now we have in the next page. Here we have next page, electronic configuration of the each element. Suppose helium, hydrogen, what we have? For the hydrogen, I have 1s1. This 1 represents n value. N is equals to 1. This S represents L equal to 0. See here, in LS, L equal to 0, N equal to 1, we have 1. Next helium, 1s2. Under this is N equal to 1. This is L equal to 0. Next take lithium. For lithium, 1s2, 2s1. For lithium, we have 1s2, 2s1. This is n equal to 1. This is n equal to 2. This is S n equal to 0. This one also L equal to 0. Suppose I am taking 20th element. Suppose I am taking 20th element. What is the electronic configuration of 20th element? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Here up to 10th element. Same way, check 13th element. Up to 20 is common. Next is 21 element. 21 element. Here 20 element is completed. Here 2 plus 2 plus 6, 10, 11, 12, 12 plus 6, 18, 18 plus 1, 19. Here 2 plus 2 plus 6, 10, 12, 17, 18, 19. Here this is 6. 6 plus 2. Like 30 elements is there. How we are writing electronic configuration is explained in the periodic table, which shall like that it is explained for different elements, which it is belongs to which period, all those things is explained in the periodic table. Next, after periodic table, now we will see the next one is molecular spectra of the atom. We will see molecular spectra. A molecular spectra. This molecular spectra is configured as electronic spectra, rotational spectra, and vibration spectra. If the spectra rises due to the molecules, it is called as a molecular spectra. If the spectra arises due to the atoms, if the spectra is arise due to the atoms, it is called the atomic spectra. If the spectrum is arised due to the molecule, it is called as molecular spectra. It is called as molecular spectra. Electronic angular momentum is not conserved in molecules. So, the molecular energy states is not specified in this. Electronic angular momentum are not consumed in molecules. Electronic angular momentum is not consumed, not conserved in molecules. So, it is not specifying in that. Whereas in diatomic molecule, the total charge is distributing in the symmetrical about its nuclear axis. So, whereas in diatomic molecule, the total charge is distributed in the middle of the atom. So, the angular momentum about the axis, is conserved. Angular momentum about the axis is conserved. In this, the nuclear motion is not be neglecting. The nuclear motion is not neglecting the atomic molecules, the nuclear vibrating about the nuclear axis, internuclear axis. In the atomic molecule, the vibration is taking place across the internuclear axis. And the whole system is rotating about the center of the axis. And the whole system is rotating about in the center of the mass. Here, both vibrational and rotational motion, both motions are quantized. Here, both motions are quantized. According to them, an excited energy levels of a molecule for the fixed electronic states. Here we are discussing about 3. Here I am discussing about the electron. Again, I am discussing about rotation. Again, I am discussing about vibration. So what are the things we have to concentrate about electronic, rotation, and vibrational spectrum? In electronic spectrum, excitation of the excited state of the atom results in the excited station of the molecule. Here, the energy is measured in terms of electric volt. Here, the energy is measured in terms of electric volt. Whereas in rotational spectra, rotation of the molecule, energy levels are separated by 0.001 electric volt. This 0.001 electric volt is for rotation of the molecule. Whereas for the electronic spectrum, what we have to write? For the if the excitation of the atom takes place, then excitation of the molecule is also taking place and it is measured in electric volt. Whereas in rotation, the separation between the energy levels is 0.01 electric volt. Whereas come to the vibration of atoms, the energy separation is 0.1 electric volt. The energy separation is 0.1 electric volt. Again, we will find this molecular spectrum in is categorized in three types. It is a superposition. It is a combination of three types. What are the combination of three? First one is electronics. Second one is rotational. Third one is vibrational. What happening in this? In electronic spectra, which region we are observing? Electronic spectra is observed in heteronuclear as well as in homonuclear molecules. So this electron spectrum we are observing in heteronuclear molecule as well as in homonuclear molecule, and it is observed both in emission and absorption. We are observing this one in both emission and absorption. Also, we are seeing this one in visible and ultraviolet regions. Suppose if the spectrum consists of large number of bands, we have band head. We have band head. So first we discussed what is electron, what is rotational. Rotational is observing 0.01 electric volt. Vibrational is observing in 0.1 electric volt. Up to here is completed. Again, we are seeing this one in, it is a superimposition of three regions. The first region is electric spectrum. The first one is electronic spectrum. Second one is a rotational spectrum. Third one is vibrational spectrum. Electronic spectrum, as we have continuous series of bands, the bands are very close to each other. The intensity of the band is called as band head. The intensity of the band is called as band head. And across the band head, the intensity is suddenly falling to zero. At that time, what happens? This intensity is moving towards the gradually to the another band. Each spectrum consists of large number of bands. Each individual band has a sharp edge. Oka band ki edge anedi sharp ga undi. Each individual band has a sharp head. That sharp head is called as a band head. And the intensity of the band head is falling to zero. If the intensity of the band head is falling to zero, this is gradually moving to other side of the band. Second type of is rotational spectrum. This rotational spectrum where we are observing this rotational spectrum, we are observing heteronuclear diatomic molecules. And here the energy range is 0.01 electric volt. And where we will observe this one, we will observe this one in this spectrum is observed in heteronuclear or homonuclear. This spectrum is observed in diatomic molecule in far infrared region as well as in microwave region. So this is observed in microwave region and far infrared region. In far infrared region, it is observed from 10 power 6 to 10 power 7. In microwave region, it is observed from 2 to the power of 7 to 2 to the power of 10 power 8. And what is the energy level? The energy level is 0.01 electric volt. Next, third is rotational spectrum, vibrational rotational spectrum. Next, vibrational rotational spectrum, we are observing this one in near infrared region. We are observing this one in near infrared region from 10 power 4 to 10 power 6. 10 power 4 to 10 power 6 we are observing. And also it is observed in heteronuclear molecules. It is observed in heteronuclear molecules. And it consists of intense band always as weak band. Those two types of band is there. Just overview of this, we will see. Three types of spectrum. What is the first one? First one is electronic spectrum. Second one is rotational spectrum. Third one is vibration. In electronic, energy range is 0.01 electric volt. Here, vibrational spectrum, the energy range is 0.1 electric volt. Where we are observing this one. It is the important task or point to observe where we are observing this one. Here we are observing this one in. We are observing this one in heteronuclear diatomic molecule. We are observing this one in heteronuclear diatomic molecule. Whereas rotational spectrum, we are observing microwave region. Microwave region. Also, we are observing this one is for infrared region. For infrared region. Next, vibrational spectrum, we are observing this one. Where we are observing this one? This one we are observing in near infrared region. We are observing this one is near. We are observing the near infrared. And here on which range we have? This one we have 10 power of 4 to 10 power 6. This one we are observing from 10 power 7 to 10 power 8 angstroms. First one we are observing in diatomic heteronuclear molecule. So this is the topic about which one we discussed. This is the topic of 2.6. This is the topic of 2.6. Page number is how much? Page number 29. In page number 29, what is this topic? This topic is about molecular spectral. This topic is about molecular spectrum. So unit 2 is completed. Next we will go to the unit 3. In unit 3, we have two top. Unit 3 is already completed. Now we will see the unit 4. In unit 4, what are the things we are going to discuss now? In unit 4, I will complete Schrodinger wave equations. In the Schrodinger equation, we have two types: time-dependent wave equation and time-independent wave equation. Time-dependent and time-independent wave equation. We will see. First, from unit 4. Next, I am starting unit 4. From unit 4, we have two important topics. What is the first topic in unit 4? In unit 4, we have two important topics. That is time-dependent Schrodinger wave equation. We will see the time-dependent Schrodinger wave equation. Time-dependent Schrodinger wave equation. First, we will start derivation part. The derivation part will start from energy. Energy equation we have. E is total energy. What is E? E is total energy. If V is velocity or V is called speed, and if M is mass of the electron, M is mass of the electron, then we have energy equal to kinetic energy equal to half mv square. Multiply and divide both sides with m. We will get m square v square by 2m. So multiplying and dividing with mv, we got m square v square by 2m. Consider m square v square. Consider m square v square is equal to p square, because what is the formula? Because we have p equal to mv. If I am considering m square v square as p square, then what we will get? Then we will get energy equation. Then we will get energy equation. Then we will get energy equation E equal to P square by 2m. E equal to P square by 2m. This is equation number 1. Next, we know few more formulas. What are the formulas we know? P equal to h by lambda, one formula we have, and another formula we have E equal to h nu. E equal to h nu. Based on these formulas, next I will do derivation part. Let a wave associated with a particle. Next is a wave associated with particle. A wave associated with a particle can be represented as, we have a wave associated with a particle can be represented as psi1 equal to a1 cos a1 cos a1 cos 2 pi x by lambda minus frequency nu times of t. This is the first equation. Next, I am taking another equation. This equation is taken for incident. This is taken for incident wave. Similarly, I am taking another equation. I'm taking another equation psi 2. This equation is taken for reflected wave A2 times of cos 2 pi x by lambda times of frequency nu times of t. This wave I am taken for reflected wave. This is for what is incident wave. Another one is reflected wave. Next superimposition of these two waves has to be right. This is for reflected wave. Next superimposition of two waves. After superimposing of two waves, after superimposing of two waves, I will get psi equal to psi 1 plus psi 2. Now what is psi 1 plus psi 2? We will get psi equal to 2. By adding 2, the equation is 2a times of cos 2 pi x by lambda. Next, cos 2 pi nu times of t. This is the main equation we have after superimposing of psi 1 and psi 2. After superimposing of psi 1 and psi 2, which is represented as equation number 3. The equation 3 is the product of two terms. Equation 3 is product of it's the product of two terms. Next, here I am taking one is space term, another one is time term. Here, which is the space term and which is the time term? Whatever the term we have 2 pi x by lambda. This 2 pi x by lambda term is the space time. 2 pi nu time is the time period. Here this is the space. Space time is 2 pi nu by t. Space time. Here the space time we will take as 2 pi x by lambda. Next time, space. What time? Space term. The space term is 2 pi x by lambda. Whereas another term we have, the term is time. Time term is equals to 2 pi nu of t. Using these two equations, I am writing two separate equations again. So the spatial dependent term is based on these two. Based on these two. Now I am writing the spatial what is the spatial dependent term? The spatial dependent term xi of x equal to 2a times of cos 2 by x by lambda. Next is the time dependent term. Next we have time dependent term. The time dependent term. What is the time dependent term? F of t equal to a times of cos 2 pi 2 nu t, not 2 pi, 2 times of nu t. This is time dependent term. So in general, we have psi of x comma t is written as, in general, psi of x comma t is written as, in general, psi of x comma t is written as tau square psi by tau x square, which is equals to 2 minus times of 2 pi by lambda whole square of psi. Based on this one, I will derive the equation. Since psi of x comma t can be written as psi of x dot psi of t. Based on this one, now I will derive. Next, as we know, p equal to h by lambda. Another formula from this, I am writing 1 by lambda equal to p by h. What is 1 by lambda? 1 by lambda equal to p by h. Now I will substitute this one here. In this place, I will substitute. After substituting in this place, I am getting equation tau square x by tau x square is equal to 2 minus 2 pi is writing as it is. In place of 1 by lambda, I am substituting p by lambda times of 2 pi whole square p by lambda whole square. We have square now. Dou square by dou psi square is equal to minus 4 pi square. Dou square by dou psi square is equal to dou square psi by dou psi square is equals to. This square is not for minus as it is 4 pi square. In place of 1 by lambda, I am substituting p square by h square. This is h not that wrong. This is 1 by lambda equal to p by h. 1 by lambda equal to p by h into p square by h square minus 4 pi square p square by h square kind of psi. This is the equation. Neat, I am rewriting the same above equation. I am getting d square psi by dx square is equal to what we got minus 4 pi square times of p square by h square of psi. P square of h square of psi. I am taking this as equation number 4. This is equation number 4. Next, in place of P, I will substitute energy equation. Now, next one is total energy equation. Total energy equal to kinetic energy plus potential energy. In place of kinetic energy, I am substituting P square by 2m, which we got previously from equation 1, plus V I am writing. Next, P square by 2m, I will get E minus V. Next, I will get P square value. Next, I will write P square value. P square value equal to 2m times of E minus V. This P square equal to 2m minus C. This is equation number 5. Next, what we have to do? Substitute equation 5 in equation 4. What is equation 4? Dou square psi by dou x square equal to minus 4 pi square times of p square by h square times of psi. So, substitute this fifth equation in fourth equation. Next, further simplification. Which one we are discussing? We are discussing time independent wave equation. We are discussing time independent wave equation after substituting substitute equation 5 in equation 4. Substitute equation 5 in equation 4. Then we will get dou square psi by dou x square is equals to minus 4 pi square by h square times of 2m times of E minus V. Right. Further, 2 multiplying outside, we will get minus 8 pi square m by h square times of E minus V of psi. What we got? We got dou square psi by dou x square. After this, rewrite the above equation. What we will get? Rewriting above equation, we will cross multiplication h square by 8 pi square m times of dou square psi by dou x square plus E minus V of psi equal to 0. This is the main equation. Which equation? This is the main equation and this is one of the important essay question. What is this equation we got? This is time dependent wave equation. What are the equation we got? This is time time dependent wave equation. Whatever we've got, this is time dependent wave equation. So here, as we know, what is h dash? As we know, h dash equal to h by 2 pi. So again, I am rewriting this equation. How I am writing? H dash h by h square by 8 pi square ఉంది కదా, దాన్ని ఎలా రాస్తున్నానంటే h by 2 pi whole square రాస్తున్నాను. h by 2 pi whole square times of 1 by 2m times of dou square psi by dou x square, dou square psi by dou x square plus e minus v of psi equal to 0. H by 2 pi I am writing as h dash square by h dash square by 2m times of dou square psi by dou x square plus e minus v of psi equal to 0. So this equation is what? Whatever the equation we got is time independent Schrodinger wave equation. Whatever we got is, this is time independent. Time independent Schrodinger equation. You will see this one in the screen share part. What is Schrodinger wave equation? First, what we took, E equal to half mv square. First equation is E equal to half mv square. Multiply numerator and denominator with m. What we got? M square v square by 2m. This mv I am taking as a p, taken as p square by 2m. This is the first equation. Also, we have momentum equation. What is momentum formula? Momentum formula equal to h by lambda. Another formula we have, energy equation E equal to h nu. Based on this, I am writing two Schrodinger equations. Psi1 equal to a1 cos 2 pi x by lambda of nu t. Psi2 equal to a2 cos 2 pi x by lambda of nu t. Where this 2 pi x by lambda is taking as a space term, nu 2 I am taking as a time term. And combining superimposing of these two is psi1 equal to psi1 plus psi2. Adding these two constant a1, a2, I am writing as 2a times of 2 pi x lambda, 2 pi nu t. This is the product of two terms, where space term is written separate and time dependent term is written separate. Psi of x equal to 2a cos 2 pi x by lambda. This is the space term, and time period time is f of t equal to a cos 2 pi nu t. This is the time term, space term and time term. So general equation, what we have general equation? General equation is dou square psi by dou x square is equals to minus 2 pi by lambda. This 2 pi by lambda, I am keeping whole square of psi. This one, I brought one equation, that equation number 4. Next, I took from energy equation, I am substituting p square value in the equation. And after simplifying, final equation is, what we got final equation? Final equation is equals to h dash square by 2m times of dou square psi by dou x square plus e minus v of psi equal to 0. This is the Schrodinger time independent equation. Same way now we will see the Schrodinger time dependent equation. I will explain in this time dependent equation. Directly dependent equation I will explain in this. What is psi? First equation we have. As we have short time, I will explain instead of on board. Directly I will explain on the screen. What we have psi? Psi equal to a cos 2 pi I times of x by lambda of nu t, where here nu is the frequency, lambda is the wavelength. As we know another equation, what is E equal to h nu, and one more equation we know what is h dash. H dash is equal to h by 2 pi. Based on these two equations, we will simplify further. Here E equal to h nu. In E equal to h nu, in place of h, I am substituting 2 pi h dash. In place of h, I am substituting 2 pi h dash. Here, from h dash equal to h by 2 pi, what we will get h equal to h dash times of 2 pi. that one is substituted and written energy equation, that is here. Again, one more equation, lambda equal to h by p. In place of h, I am substituting what? 2 pi h dash. In place of h, I am substituting 2 pi h dash by p. So we have equation lambda equal to 2 pi h dash by p. From this, I am writing p by h dash. What we will get p by h dash? P by h dash I will get 2 pi by lambda. 2 pi by lambda. This is from this first time dependent equation, first part. Next, what did substitute 2 in 1? What is 2? What is 1 here? 2 is 2 pi by lambda equal p by h dash. From this, I am substituting only lambda value. 2 pi I is as it is, x is as it is. In place of lambda is substituted. The topic is time dependent wave equation. In time dependent wave equation, what is the general formula? General formula is I equal to a times of exponential times of 2 pi I x by lambda minus nu of and second where what is nu? Where nu is the frequency, lambda is the wavelength. And we know E equal to h nu. And another formula we know h dash equal to h by 2 pi. From this h equal to 2 pi h dash. H equal to 2 pi h dash. Substitute this one in this equation. Then what we will get energy equation after substitution? After substitution, the energy equation E equal to, in place of H, I am substituting 2 pi H dash of nu. E equal to 2 pi H dash of nu. Next, we have another formula. What is another formula? Lambda equal to H by P. Lambda equal to H by P. In place of H, I am substituting 2 pi H dash by P. So what we got lambda? Lambda is equals to 2 pi H dash by P. From this, P by H bar, H dash I am taking. P by H dash is equals to what? 2 pi by lambda. So, in the first equation, we have here 2 pi is there, here lambda is there. So, in place of 2 pi by lambda, I am substituting P by H dash. In place of P by H dash, I am substituting P by H dash. So, this is equation number 2. That is equation number 1. Next, what we have to write? Substitute 2 in 1. After substituting 2 in 1, what we will get? After substituting in 2 in 1, we will get equation. After substituting 2 in 1, we will get psi equal to a times of exponential time of I by h dash p. P by h dash 2 pi by lambda place lo p by h dash పెడుతున్నాం. P of x minus e of t time period. E of t. This is the equation. This is the value of psi, which I am writing this as a equation 3. What is this one? This is equation 3. From this, I am writing dou psi by dou x. From this equation, I am writing dou psi by dou x. Differentiate equation 3 with respect to x. ఇక్కడ x term ఏముంది మనకి p ఉంది I ఉంది అవునా pi by h dash ఉంది so I only x term through differentiate చేస్తున్నా p I p by h dash of a remaining term as it is వచ్చేస్తుంది a exponential of I by h dash p of x minus e of t. ఇది dou psi by dou x. నెక్స్ట్ దీనికి dou square psi by dou x square చేద్దాం. dou square psi by dou x square అంటే మళ్ళీ ఇంకొకసారి డిఫరెన్సియేషన్ చేయాలి విత్ రెస్పెక్ట్ టు s. అప్పుడు మళ్ళీ ఏమొస్తుంది ip by h dash మళ్ళీ బయటికి వస్తుంది. సో 2 times అవుతుంది I square p square by h dash square times of a times of exponential of I by h dash p of x minus e of t. మనకు I square అంటే ఎంత వాల్యూ -1. I square వాల్యూ ఎంత -1. అప్పుడు మనకి ఇక్కడ ఏమొస్తుంది dou square x by dou x square is equals to minus p square by h dash square minus p square by h dash square times of the a exponential of whole is as it is xi గా రాస్తాను of xi. సో మనకి ఇది ఇప్పుడు వచ్చింది ఈక్వేషన్ నంబర్ ఎంత ఇది ఈక్వేషన్ నంబర్ 4. సేమ్ ప్రీవియస్ గా చేసినట్టు p వాల్యూస్ సబ్స్టిట్యూట్ చేయాలి. నెక్స్ట్ ఫ్రమ్ 4 మనం ఏం రాయొచ్చు h dash square of dou square psi by dou x square equal to minus p square of psi. ఎంత ఇది ఈక్వేషన్ నంబర్ 5. సో ఇక్కడ ఏం చేసాం మనము ఈక్వేషన్ 3 ని డిఫరెన్షియేటింగ్ విత్ రెస్పెక్ట్ టు x గా చేస్తున్నాం కదా దీన్ని మనం డిఫరెన్షియేట్ విత్ రెస్పెక్ట్ టు x త్రూ డిఫరెన్షియేట్ చేసినాము. మనం ఇప్పుడు ఏం చేద్దాం డిఫరెన్షియేట్ విత్ రెస్పెక్ట్ టు t చేద్దాం. నెక్స్ట్ వీ హ్యావ్ టు డూ డిఫరెన్షియేట్ విత్ రెస్పెక్ట్ టు t. డిఫరెన్షియేట్ విత్ రెస్పెక్ట్ టు t టు ఈక్వేషన్ 3. ఈక్వేషన్ 3 ని విత్ రెస్పెక్ట్ టు t చేస్తున్నాడు. అప్పుడు ఈ టర్మ్ బయటకు వస్తుంది. ఎక్స్ టర్మ్ చేసినప్పుడు p టర్మ్ బయటకు వచ్చింది. ఇప్పుడు ఈ టర్మ్ బయటకు వస్తుంది. అప్పుడు ఏం రాయాలి dou psi by dou t విత్ రెస్పెక్ట్ టు t చేస్తున్నాను. ఇది కింద రాద్దాం. Differentiate with respect to t. Differentiate with respect to t చేస్తే ఏమొస్తుంది dou psi by dou t is equal to minus I e by h dash a times of exponential of I by h dash times of p of x minus e of t. నెక్స్ట్ దీని ఎట్లా రాయొచ్చు dou psi by dou t equal to dou psi by dou t equal to minus I e by h dash of psi. సో మనకి ఇప్పుడు dou psi by dou t వచ్చింది. ఆఫ్టర్ dou psi by dou t దీన్ని e of psi rewrite చేస్తే e of psi equal to minus h dash by I times of dou psi by dou t. This is equation number 6. నెక్స్ట్ ఇప్పుడు ఏం చేయాలి మనం? మనకి ఈ సై వచ్చింది. డిఫరెన్షియేట్ విత్ రెస్పెక్ట్ టు టీ చేస్తే ఈ సై వచ్చింది. డిఫరెన్షియేట్ విత్ రెస్పెక్ట్ టు పి చేస్తే పై సై వచ్చింది. సి ఆఫ్ సై వచ్చింది. ఇప్పుడు ఈ ఆఫ్ సై, ఫై ఆఫ్ సై రెండు తీసుకొచ్చి మనము మెయిన్ ఈక్వేషన్ లో సబ్స్టిట్యూట్ చేయాలి. ఇప్పుడు ఈ మన ఈక్వేషన్ ఏమొచ్చింది? టోటల్ ఎనర్జీ టర్మ్ the total energy term equation మనకి ఏముంది? P square by 2m plus V ఉంది. దీనికి psi తో మల్టిప్లై విత్ psi, మల్టిప్లై విత్ psi మనకి ఏమొచ్చింది? E of psi equal to P square by 2m of psi plus V of psi. ఈ ప్లేస్ లోనేమో ఈ ప్లేస్ లో ఈక్వేషన్ 6 సబ్స్టిట్యూట్ చేయండి. నెక్స్ట్ పి ప్లేస్ లోనేమో ఈక్వేషన్ 5 ని సబ్స్టిట్యూట్ చేయాలి. ఇన్ ప్లేస్ ఆఫ్ 5 సబ్స్టిట్యూట్ equation 5 after substituting t, after substituting this is equation 8, this is equation 8. Substitute equation number 7, equation number 5 in 8th equation. After substituting in 8th equation, what we will get? Minus h dash by I times of dou psi by dou t equal to minus h dash square by 2m times of dou square psi by dou x square plus v of psi. From this minus 1 by pi కి వచ్చేస్తే I h dash అవుతుంది. I h dash dou psi by dou t equal to 2 minus h dash square by 2m times of dou square psi by dou x square plus v of psi వచ్చేసింది. Next make psi common. I h dash dou psi అయిపోయింది. dou psi by dou t equal to 2 minus h dash square by 2m plus v minus h dash square by 2m dou square by dou x square plus v మొత్తం బ్రాకెట్ పెట్టి psi పెట్టారు. బ్రాకెట్ పెట్టి psi పెట్టారు. సో నెక్స్ట్ దీన్ని రాయాలి. I h dash dou by dou t of psi, dou by dou t of psi is equal to minus h dash minus h dash square by 2m dou square by dou x square plus v of psi. దీని ఈ టర్మ్ ని మొత్తం ఈ psi అనుకుంటాము. ఈ టర్మ్ మొత్తం h psi అనుకుంటాం. సో దిస్ ఇస్ షార్డింజర్ టైం. ఫైనల్ గా మనకి ఏం ఈక్వేషన్ వచ్చిందమ్మా? షార్డింజర్ టైం డిపెండెంట్ ఇండిపెండెంట్? టైం డిపెండెంట్ వేవ్ ఈక్వేషన్ వచ్చింది. ఫైనల్ ఈక్వేషన్ మనకి ఈ psi ఈక్వల్ టు h psi వచ్చేసి. వాట్ ఈస్ ఈ హియర్? ఈ ఈక్వల్ టు 2 మనకు వచ్చింది. ఈ వాల్యూ ఏమొచ్చింది? I h dash dou psi by dou t వచ్చింది. నెక్స్ట్ h ఏమొచ్చింది? మైనస్ h dash by 2m times of dou square by dou x square plus v వచ్చింది. So Schrodinger time independent equation is E psi equal to H psi.